All right, let's treat alkynes, please. Take down, please. Definition, alkynes, definition, please. Alkynes are hydrocarbons with the carbon-carbon triple bond. I said you can easily write down by writing this. You can easily do that by this. This means carbon-carbon triple bond. So this one here, that's carbon-carbon triple bond. Right. They are hydrocarbons with the carbon-carbon triple bond and have the general molecular formula of CnH2n minus 2. We've said this before in our previous class. So they have the general molecular formula of CnH2n minus 2. Full stop. The simplest member of the alkyne group is ethyne. Simplest member of the alkyne group is ethyne. Ethyne is C2H2 and it's also called acetylene. So the simplest member of the alkyne family is ethyne, and ethyne is also called acetylene. It has a formula of C2H2. That's it. In other words, if you look at the system of naming compounds, it's usually met, et, prop. We are saying for the alkynes, there is no met for alkyne. In other words, in quotes, methyne does not exist. So this does not exist. So the first member there is ethyne. Do you all know why? You all know why? Yes. Let me just stress it. For methane, we said we need just one carbon. That's for met, one carbon. And for an alkyne, we said there must be a triple bond. So one carbon, triple bonded to what? What exactly? It won't work. You can't put hydrogen here because hydrogen needs a single bond, so it won't work. In other words, the simplest member, I have to put another carbon here. So it becomes C123. We said for any carbon atom to be stable, it must have 4 bonding in quotes. So I'm having 1, 2, 3. I'll add one here to make it 4. So this one now is now balanced. This one here becomes 1, 2, 3. I'll add one here to make it 4. So hydrogen needs just 1 bonding, while carbon needs 4. 1, 2, 3, 4. In other words, I now have C2H2. That's ethyne or acetylene. That's the idea. Next up, please. Preparations of alkynes. Preparation of alkynes. The different methods, take down please. Preparation of alkynes. That's a new subtopic. Before we proceed, alkynes, is it saturated or unsaturated? All right. Okay, so preparation of alkynes, please take down. The methods of preparing alkynes include the methods of preparing alkynes include number 1, the hydrohalogenation of alkyl halides. The hydrohalogenation of alkyl halides. This involves reacting an alkene. This involves reacting an alkene, E-N-E. This involves reacting an alkene with a molecule of a halogen. Reacting an alkene with a molecule of a halogen, comma, leading to the formation of a dihalide. Leading to the formation of a dihalide comma, which then combines with potassium hydroxide, which then combines with potassium hydroxide to form a haloalkene, to form a haloalkene which finally reacts, said haloalkene, which finally reacts with sodium amide. Sodium amide is NaNH2. We'll explain why this is so in subsequent classes. With sodium amide, this way, sodium amide, this way, sodium amide to form an alkyne. Sodium amide to form an alkyne. Full stop. The equation of the reaction is given below. Just in case you mixed it, please check your work again, please. I said this involves reacting an alkene with a molecule of a halogen, leading to the formation of a dihalide, which then combines with potassium hydroxide, that's KOH, to form a haloalkene, which finally reacts with sodium amide, that's NaNH2, to form an alkyne. On your own, please, can you list out the equation of reaction, please? Look at what you have there. Try to see if you can figure it out before I do it, please. Now, look up, please. Let me do it, please. Now, usually, I shouldn't be doing this stuff again because we've passed this stage. I'll just write it and you understand. But for the sake of our first timers, let me explain this again. So, look up. So, how do we get this man? The idea of teaching you like this is to make you think, right? If you can think out these stuffs at this point, it becomes easier for you to study on your own, understand. But then let's see what we have here. They said this involves reacting an alkene. Now, listen, you're writing equation of reaction, and I want to write alkene. For an alkene, what comes to mind there? Double bond. So my first task is to put C double bonded C. This is an alkene. So that's all. This is an alkene. So for an alkene, it's just C double bonded and I have this. And I said, please, for this one here, you don't put the H. You don't. Why? I'm doing a general equation. So just leave it like this. So this is an alkene. That's all. They said an alkene reacts with what there? A halogen. For organic chemistry, halogen, what do we use to represent halogen? X. So for a halogen, is it X or X2? Huh? X2. Why is it X2? Because halogens are what there? Diatomic. That's all. So it becomes an alkene. This plus a halogen becomes X2. X2 because halogens are what there? Diatomic. All right. Proceeding. They said reacts with an alkene to give what? To give what there? A dihalide. When you hear di, what comes to mind? 2. So a dihalide, that means 2 of halogen. Check your previous notes, previous class, we did dihalide there. And for a dihalide, listen, obviously I'm going to continue with these 2 carbon here. So I'm having carbon here and then carbon here. For a dihalide, I'm having 2 halogens. It means one halogen will take here, the other one will now take here. I'll now take 1, 2, 3, 4. So I'm having this. This is a dihalide because I have 2 halogens taking separate position. And observe is now an alkane. So I'm having this. What else? They said the dihalide combines with what there? Potassium hydroxide. That's KOH. So I'm having KOH, potassium hydroxide. Next up, so it gives you what there? What's next in there? Haloalkene. If you hear haloalkene, when you hear halo, what comes to mind there? Halogen. And what again there? An alkene. How do you represent alkene? This same thing here. So it becomes C double bonded to C. This is an alkene. To make this one a haloalkene, that means this man must have what there? A halogen somewhere. That's the idea. So somewhere here, I'll just put perhaps a halogen. Let's say either up or down, whichever one is okay. Let me use down. So I'm having this. So this becomes 1, 2, 3, 4. Don't forget, you don't close it. You don't put H. Leave it there. So this is now a haloalkene. 1, 2, put 3, and perhaps 4 if you want to. Please observe. This is a haloalkene. Halogen and alkene. They did not say dihaloalkene. If it was a dihaloalkene, perhaps I'll now have 2 here. So please observe why I'm having just one halogen, because it's haloalkene. All right. After haloalkene, what next there? Sodium amide. That becomes NaNH2. To give you what there? What's next in there? An alkyne. If alkene is C double bonded, alkyne will be what there? C what there? Triple bonded. As simple as this. This is the correct equation of the reaction. So it's quite easy. Just know how I follow it step by step. So I have this. So this becomes the equation of the reaction. So I have this. Please copy down. Let's proceed, please. Let me show you how I do this stuff. Don't give it, in quotes, a chemist approach. Give it a mathematical approach. Just match up terms. What do I mean? For this one here, I'm saying use a propene. Use propene. For this one here, use prop. A prop compound, and use X as bromine. So let's use prop and bromine to complete this reaction. What do we have? First things first, here I have to be propene. For prop, I expect 3 carbons. That's prop. So it becomes 1, 2, 3. So I'm having this. This is my prop. But for the fact that this one has to be an alkene, that means somewhere here I should have a double bond. So I'm having this one here. So please observe. 3, 1, 2, 3 gives it a prop. But they say alkene. So I'll add double bond here. Complete this one. I'm having 1, 2. It needs 2 more. So it becomes 3 and 4. I'm done. 1, 2, 3, 4. I'm done. 1, 2, 3, 4. I'm done. Plus, next up, X should be bromine. They say X2. So it's as simple as Br2. That's simple. Moving on, the next one here, I've said this stuff gives you corresponding. In other words, if I have 1, 2, 3 carbon here, I must also have 1, 2, 3 carbon. So I'm having 1, 2, 3 carbon. Of course, connects this. Observe that in this one here, I have just single bond. There are no double bonds. The only difference is that for this compound here, 2 carbons are bearing X and X. So my question will now be, which 2 carbon here should bear the X? This and this, or this and this. So it's as easy as go back to the carbons. The 2 carbon bearing the double bond should be the one bearing the halogen. In this case, it was this carbon and this carbon. In other words, these 2 carbon will now have the X and X. So this one here, since it was this and this, I'm taking this and this one here. We said X should be Br, so I'm having Br here and then Br here. If I'm done with this, complete this compound. I have 1, 2, 3, and 4. 1, 2, 3, 4. 1, 2, 3, 4. I'm done with this one here. Next up, they said KOH, potassium hydroxide. I'm done. Coming to this, now for this one here, since I use 3 carbon, of course I said you maintain the same 3 carbon idea. 3 carbon, so here so I'll have 1, 2, 3. 3 carbon first. Then observe that in this one there's a double bond. So that means I'll have to I'll have to bring back my double bond. Come back to this. It was these 2 having double bond. So I'll just simply come here. These 2 having the same double bond. The difference now is that this one here, the one by the left of the double bond, has the X, a halogen. So here now, the one by the left, this one here, should now bear the halogen. That's simple. So from here, X is Br, so it becomes Br. Try to complete this. This one is 1, 2, so put it here. 1, 2, 3, 4. This one is balanced. 1, 2, 3, and 4. Balanced. 1, 2, 3, and 4. Balanced. I'm done with this. Next up, sodium amide. So NaNH2. NH2. Finally, they said an alkyne. So first things first, 3 carbon, 1, 2, 3. Where exactly should I put my triple bond? Should it be in between these two or this one here? Go back to your initial one. I use this last two. So in this case here, this one here should have triple bond. Complete the structure, put this here. So I'm having 1, 2, 3, 4. This one is balanced. 1, 2, 3. One more, that's balanced. 1, 2, 3, 4. So look at this. It's not record signs. Just use your eyes, follow them up, and that's all. The next task now be naming them. How do you name them? For this one here, what do you have here? What's this? Is it propene or propone? Whatever you use, if you're here, I know I stressed this in the previous class, that there is no propene. Propene does not exist. So you can leave it as what there? Propene if you want to. If you want to put propone in, no problems. But understand that if you put propone in, there is no propene. So if there's no propene, why are you bothering about propone? So propene, I'm done. This one here is what? Bromine. For this one, how do you name this? What have you? 1, 2, Abi? So because what there? The name of this one becomes 1, 2, what there? Dibromo. 1, 2, 3. 3 is what there? We are done with how to name compounds. So this should be a problem. So this one is 1, 2, dibromo propane. How do you name this man here? Huh? Is it 2 bromo or 1 bromo? Hold on. For this, okay, 2 bromo what? 2 bromo, 2 what? Right? Hang on. For this compound, my numbering, am I numbering left to right or right to left? It has to be right to left. Why? Because we said for an alkene, my priority is what there? The double bond. If I number this way, I'm having 1, 2. Is carbon 2 before double bond? If I number this way, is what there? 1. Carbon 1 bears double bond. So our number this way becomes 1, 2, 3. So the name becomes what there? 2 bromo. So this one becomes 2 bromo. 1, 2, 3. That becomes what there? Prop 1 in or propene. 2 bromopropene or prop 1 in. Same thing. We're having 2 bromopropene. Then what do you have here? Propane. So it's this easy. So just use your eyes, follow them up, and that's all. First carbon, this one here. This one here. So somebody's asking, what if you put the bromine here? So it becomes 1 bromo propene, right? Propene now, prop 1 in or propene. So what if you put the bromine here? Well, listen. Chemistry is not like maths where you can manipulate it, right? So here's always my advice. The reason why we give you, look up, the reason why we give you, what's it called? The reason why we give you general form equation is so that you can follow it up. What do I mean? At this stage, if I were you, I know that one of these carbon must bear X. So if I were you, what do I do? The question now be, for these two here, the double bond was between this and this. So from my general form, which of them bore the X? Was it carbon to the left or to the right? To the left. So I'll come here to the left. That's it. That's what you have. So this is more like a guide to writing the equation. So if you put it right, you may not be totally wrong, but know that 1 bromopropene and 2 bromopropene may look alike, but they might have different chemical properties. They might have different chemical properties. So to avoid the whole chemical property saga, put it as they gave you. They said the one by the left. So that's the idea.
Alright guys, don't forget that you can get the complete organic chemistry course on my website. Simply visit www.jonahemmanuel.com/courses and then you see the organic chemistry full course. Alright, it gives you access to my detailed lecture on all the homologous series from alkanes, alkenes, alkynes, alcohols, ether, esters, including their nomenclature, their preparation, and all the reactions they undergo. All right, or you can simply join my organic chemistry channel membership to get access to these video lessons. All right.